Hey everybody, so Objective 37, we're going to jump right into it. Hope you guys are feeling rested after your week off. You're not too bored, because there's not much to do, but there's always math to do. There is always math. So let's start talking about cylinders here. A cylinder is a figure, is a solid that we're really familiar with, honestly, because we see them all the time. So let's just get a definition so that, again, we're being precise about what we're talking about. So a cylinder is a solid. Remember, we talk about solids are three-dimensional figures that, can have space fill up inside them. So a cylinder is a solid with two parallel circular bases and a curved surface that connects the bases. Okay, so a solid, right, three-dimensional, two parallel circular bases, right? Parallel meaning like they're, lined up, circular bases, and a curved surface that connects them in between. So again, we see them all the time. Paper towel rolls, right? Cans, any canned goods really, like water bottles, soda cans, like all these different things, like glass jars that you just have lying around. I don't know, it's just anything really. So we see cylinders a lot. So they got circles as bases and then a curved surface in the middle. Okay, so of course, right, we talked about soup cans, soda cans, garbage cans, all these cans, really. All right, now we just want to talk about the difference. We're mainly used to seeing a right cylinder. And when we talk about right cylinder, think about a right angle. So a right cylinder is a cylinder that has a perpendicular side to its base. So it's just standing straight up and down. So the base is perpendicular, it's a right angle to the side. It's really what we're most used to seeing. And then the other case, this is called an oblique cylinder. Oblique would just mean that somehow it's kind of like wonky, it's shifted to the side somehow. So it doesn't form a right angle straight up and down. It's got this angle, it's kind of tilted here. So we see this kind of stack of quarters that if you kind of drew a cylinder with some roundedness to it, you could kind of get an oblique cylinder. But mostly we deal with right angle cylinders. Okay, this is not on your note sheet, but just play along here, because if we can think about where formulas come from, a lot of times they're a lot easier to use, and ultimately they're a lot easier to memorize, or not so much memorize, but they're a lot easier to just, when you think of it, it makes sense, and then you can use that just going forward. So think about a prism. Okay, we know that it was length times width times height. So here's the length, here's the width, and here's the height. But really, if you think about it, think about like a stack of paper, okay? If you find the area of the first stack of paper, and then you just layer those on top of each other, and layer those on top of each other, and layer those on top of each other, ultimately, you're just going to stack all those pieces of papers however tall your height is. So the volume of a prism is you really find the area of one of the bases and you times it by the height. So this is, you find the area of one of the rectangles and then you just multiply it and fill it in by the height. So the same idea applies to cylinders. This idea about volume is that if you take the area of a base and you times it by its height. So here's our base that's on the top here. But instead of length times width, because it's not a rectangle, so the area of the base, we know that our base is a circle. And we know that the area of a circle is pi r squared. So the volume of a cylinder is simply just pi r squared times h. So our formula should be volume equals pi r squared h. That's what should go on our note sheet. This is what should go on our note sheet here. So you find the area of the base, which is a circle, and you fill it in as tall as the cylinder is. And you're making these little tiny slivers of circles, and you're just stacking them, stacking them, stacking them, stacking them, stacking them on top of each other all the way times your height. Okay, so pi r squared h, that's the formula we're going to use. So I would recommend get your calculator ready, because it's really, like I told you guys, it's really formula heavy. Really formula heavy. All right, so find the volume of a cylinder that has a diameter of 18 and a height of 22. So let's write out our formula here. Volume of a cylinder is pi r squared h. Okay, so we know the diameter is 18 and we know the height is 22. So pi is just pi and we're trying to find the volume. But here's the thing, guys, right? There's no formula that uses diameter. So we know if the diameter is 18, that means it's all the way across the circle and the radius is going to be half. So we really need to make sure the formula only uses radius. So if you're given the diameter, we just got to find the radius. Okay, cool. So we're going to use 3.14 times the radius of 9 squared times the height, which is 22. So order of operations, we know that we need to square 9 first. So 9 squared is 81 times 3.14. So 3.14 times 81 times 22. Or if you want to put it in your calculator all at once, that's cool. But we know order of operations, we got to square first. So 3.14 times 81 times 22. So your volume is 5,595.48. What was our units? Feet. And when we talk about volume, it's three-dimensional. So it's got to be cubed. Okay, so we're using the formula, plugging in what we know. Let's keep going. Find the volume of a cylinder that has a diameter of 16 and a height of 16. Use 3.14. Well, we know that the volume formula only uses radius. So if the diameter is 16, we need to take half of that, use the radius. There we go. We have r and we have h. Volume is pi r squared times h. Replace 3.14. The radius is 8 squared times the height 16. Once again, you can plug this all in your calculator, or order of operations tells us we have to do exponents first. So 8 squared is 64. So 3.14 times 64 times 16 gives us a volume of 3,215.36. Our units were feet, and volume is always three-dimensional, so it's cubed. Like I said, right, once we get kind of cooking with the formula here, now we're going to use it in different ways. So we get comfortable with the formula, and then we'll use it in different ways. Find the exact volume. Leave pi in your answer. Perfect. So when we know we're not going to use 3.14, we're just going to be exact. Okay, let's look at our diagram. What do we have here? Well, we have a measurement that goes from the center of the circle out to one edge, and we know that that's a radius. So perfect. So our radius is 3. And we look at the cylinder and we see how tall it is here. Well, looks like we're given a height of 12. So remember, right, radius has to be a part of a circle. So this radius of 3 is our radius because it shows going from a circle out to the edge. Okay, so here we go. Here's our volume formula. Pi r squared h. So we're going to leave pi. The radius is 3 squared times our height of 12. Leave pi, right? Leave it. It's just we're gonna slap it on the end there. So we're gonna leave it. So 3 squared, so pi times 3 squared is 9 times 12. And then leave pi. We're gonna leave it on the end, right? We kind of always, our symbols and our variables and our letters always go on the end. So 9 times 12 is 108 pi units, which are inches cubed. So we can find the exact volume by just leaving pi and sliding it over to the end. So that's it. All right, let's do another one. Find the exact volume of the cylinder. Perfect. Exact means we want to leave pi. Look at our diagram. Once again, we have a dimension that goes halfway across the circle, so we know our radius is 4. We have a height of 11. Volume equals pi r squared times h. Pi times our radius of 4 squared times the height of 11. 4 squared is 16 times 11. Slide the pi to the end. 16 times 11, 176 pi units cubed. Okay, pretty cool. All right, so now, once again, we know that we get comfortable with the formula, then we use it in a new way. So the volume of a cylindrical can is 100.5. So we are told the volume of a cylinder. The volume is 100.5 inches cubed. If the diameter is 4, find the height. Okay, so instead of trying to find volume, now we're just trying to find the height. So we know what we have. We have the volume is 100.5, the diameter is 4. The thing is, guys, we know the formula doesn't use diameter, so we know we're going to have to use the radius as 2, and we go find the height. So let's use our formula. Okay, what are we substituting in for V? Do we know it? We do. It's 100.5. What are we subbing in for pi? It tells us to use 3.14. What are we subbing in for the radius? It tells us we know if the diameter is 4, remember, the radius is half that, so it's 2. And then, wait a minute, we don't know h, so we're going to keep it. Okay, so now, what? So now, we are trying to isolate, oh my gosh, we want to keep advertising for the 2014 Olympics. So 2 squared is 4 times h. So 100.5, 3.14 times 4 gives us 12 point. Sochi, they are just all up in our business. Okay, we did some multiplying, so we multiplied these two to get 12.56. And now, how do we get rid of a multiplier in front? We got to divide. So we'll divide both sides by 12.56. Those cancel. We're left with h. Let's go to our calculator. 100.5 divided by 12.56. We get 8.001. Pretty close, right? I'm going to go ahead and just call it 8 inches. And remember, guys, it's just a measurement. So the units are just, it's like if you were to measure it with a ruler. So it's just 8 inches. So we're going to use the formula in a different way to help us find a different missing piece. Instead of needing to find volume, we're going back and finding height. So let's do another one here. Okay, the volume of a cylindrical can is 84.8. The diameter is 6. And we're going to use 3.14. We want to find the height. Okay, let's go to our formula. Pi r squared h. And we're going to replace everything we can. Do we know the volume? Yes. It's 84.8. Do we replace pi? Yes. We're going to use 3.14. Do we know the radius? Yes, but it's not 6, right? The diameter is 6, which means the radius must be half that. So it's 3 squared. And do we know height? No. So we keep it as a variable. There we go. Let's do a little cleaning up here. So 3.14, we know 3 squared is 9 times the height. Let's get this into one nice number here so it'll work for us. 3.14 times 9, which is 28.26 times h. And how do we get rid of a multiplier in front? We divide. Anything divided by itself cancels. Now we do 84.8 divided by 28.26, 3.0007, which I mean pretty close, really close to 3. So our height must be 3. Again, in inches because it's just a measurement. All right, so we're using the formula working a little different for us. All right, let's just see these last two problems. There is some pattern here, but really, we don't really need to use the pattern so much. Let's just find the volume. It's asking us to study the information, then calculate the volume of a circular cylinder with a radius of 8 and a height of 12. Granted, there is a pattern here, but we already know the pattern. Is you take the radius and you square it, and you times it by the height, and then you slap a pi on. So that's all we're going to do here. So let's find the volume of a cylinder with the radius of 8 and a height of 12. And we want exact answers, so we're going to leave pi. So volume is pi r squared h. We're going to leave pi. Radius is 8 squared times 12. 8 squared is 64 times 12. So the volume is 768. Slide the pi to the end. And since we don't have a measurement, we'll just call it cubic units. Oh man, that was bad. Let's see if I can connect it a little better. There we go. Okay. Last one. Do the same thing. Again, we know the pattern. It's you take the radius and you square it and you times it by the height and you make sure you got a pi there. So we want to find the volume of a cylinder with a radius 9 and height 11. I told you guys, it's super formula heavy, and sometimes that's just what geometry is. It really is. Pi, the radius is 9 squared times the height. We know 9 squared is 81 times the height. And we always put variables, letters, symbols like pi, slap them on the end. So 891 pi, because we want to keep it exact. And we don't have units, so it's units cubed. Okay, so very important that you got your calculator ready, that you got your big volume formula ready to go on your note sheet, and go for it. Get some accelerated math. You guys got it.